Hello, let's work on the light and shadow, and also let's update the parametric variation. So let me introduce a sine cos wave, and in the next class I'll generate a curve based on that. So let me start here with the generative system. Okay, so what we have on the screen, as we discussed in the last video, is 004.js. So I'm just going to start at 004.js, and so you'll find it all on my on the GitHub. So let's see. Okay, so we are referring to 005 now. Okay, so we need to work on this generative part of the code. So what we need to do is, right now the problem is that all the heights are the same, and we want to use the sliders to introduce some kind of a parametric variation, and we are thinking about a sine cos wave because it's the quickest, it's the most recognizable. So let's say that z max is an array. So we'll collect all the heights here that we want in this loop where we are generating the base or the quads. And when we generate the extrusions, we will use this z max variable arrays, z max array, and then change the height in the loop here when we actually generate the extrusion. Okay, so let's say z max. So let's say let z is equal to, we want to do a math.sine plus a math.cos here. So just sticking with the conventions. So I'm doing a sine of I and a cos of j. You can do it the other way also. And we want to, so this will be too small. So let's give it a larger variation by connecting it to the W here and the H here. H. Okay. Now when we have Z, okay, so now we have to add, we have to push the Z variable into the Z max array. Now in this loop where we are generating the extrusions, you see that we are going over each element. Now to access the Z max elements of Z max, we need a iterator. So what we have to do is we write a quads dot for each and e comma I. So when we give this argument, when we pass this argument into the function, then e becomes the elements and I is the iterator. Okay. And also we are no longer using a constant height. So we bring this e argument to our extrusion outside, I mean inside, from outside to inside this loop, and this depth here, instead of d, we make it z max of I. You can see that it's already updated and it's giving us some variations. So the first thing you notice is that it's going below the zero, the xy plane, and that's because we are starting with minus n. So to adjust that, we can do a +2. So this makes sure that everything is above the xy plane in the positive direction. So we are getting a curve now, but the variation is too much. So we can't really make out what's happening. I mean, the beauty of the or the continuity of the curve is better expressed by reducing the, yeah, now you can see the sine curve in action, and it becomes a bit more pronounced if we change the material from wireframe into, yeah, so now it becomes very clear. Okay. So we have our curve. I mean, we have the basis of a curve now. I want to focus, we'll do the curves, but I want to work on the light and shadow. So for that, get rid of the transparency. Let's make this false. Actually, the best way to do it is just comment it out. So when we need it, we can just remove the comments. Okay. So we have uh, checked. Okay. So for the light and shadow, what do we need? We need first of all to modify our renderer. Okay. Then we need to have these elements cast shadows, and then we need to receive the shadow. So let's make a ground plane first of all, where we can receive the shadow. So I'm going to make the ground plane and draw just where we have the access. Okay. We can get rid of our print statements, so console log statements. I also want to move the generate function to the place where we are grabbing the values, so we organize the code a little bit better. Okay, so there, that goes there. Okay, and so just along with the axis, I want to introduce a plane geometry. So the parameters will be length in the x-axis, length in the y-axis, number of segments in the x and y-axis, and then we can have a material is equal to new 3 dot. Let me use a mesh standard material, and we can set the color to 0x, color to white. Because it's a plane, what when we flip it around, it doesn't show. Okay, actually, let me just generate it, and then I'll show you uh, what I'm what I was going to do. Let me first generate it. So let mesh a plane, new the material. So we generated the mesh from the geometry and the material, and then we will just add it to the scene. It is black because there is no light. Note that we used mesh standard material here. If we make it mesh basic material, it won't really affect it. So 0x. But with the mesh standard material, it looks for light. And another material that we can always use is the Fong, which also looks for lighting. Okay, so let me start with standard, and then we can see. So what I was talking about earlier is that the plane is actually not double-sided, as unless we explicitly ask the material to be a double-sided material. So we do that by going to the material and adding the argument side 3 dot, sorry, dot double side. Okay, so now you can see that the material is double-sided. Next, we need to do two things. We need to cast a shadow, receive a shadow, and we need to update the renderer and add the lights. Okay, so plane dot receive shadow. So we want to receive the shadow on the plane mesh, and to every element that is being generated, we want to cast a shadow from here. So cast shadow is equal to true. So, so with that, we are done with the draw function. Now we need to add lights and we need to fix the renderer. Okay, so I'm going to do a add lights somewhere here, just above draw. Actually, we should add the lights in the draw function. Yeah, we should add the lights somewhere here. Because in the draw function, we remove all the elements from the scene at the beginning. So the light would also get removed if we only introduced them in the init function. So we introduce the lights in the draw function. So I'm going to write a function to add the light. Okay. So before we add the light, I want to update the renderer. I'm going to move this line. Okay. So we set the size of the renderer. Before that, let me say renderer dot shadow map to true. It's actually shadow map dot enabled is equal to true. Sorry, renderer dot shadow map enabled is equal to true. And we also need to specify the type of the shadow map. So this is based on the shader that the renderer uses. So we need to, in order to ask the renderer to draw lights and the shadows, we need to ask it to explicitly enable shadow map because it's a performance issue. So we need to explicitly ask it to enable the shadow map. And also we can specify the shadow map type, which is actually something called PCPF shadow map. With that, our renderer is all set to draw the lights and shadows. So all we have to do now is to add the lights. Um, Actually, what I'm going to do is I'm going to show you how to get the lights from the documentation so we don't have to remember all these. Yeah. So in the three.js org examples, I want to go to the docs and I want to look for point light. Yeah, you can see this point light and shadow. And so you can see that they've specifically mentioned all the places that we need to update in order to get the light and shadow effect. So renderer is one. Then we create the point light. I'm going to copy this bit of the code, create the point light, scene.add light, and then also the attributes of the light. Okay. So you can also grab it from three.js or don't have to remember every time. And the point light, the first function, this is the color of the light. The first argument is color of the light. Second argument is intensity of the light. Let's make it 10. And the third argument is how far away from the light source will objects receive the light and shadow effect. Okay. So those are the three arguments that go with point light. There are other things like directional light that we can see later. Okay. Then the second thing here is light dot position dot set. So that means that the position of the light, which is obvious. So let's make it around 50 in the Z axis. Remember our Z axis is facing up. So Z axis and cast shadow is true. And we add the light to the scene. Map size and width, it's sort of default, but it also depends on the specific 3D rendering that you're developing. So based on your project, you will have to modify it slightly, but for the most cases, start. It's a good idea to start from the default values and then change it. Based camera near and camera far, it's obvious that if the object is so close to the shadow and how far away from the camera. Okay. So as soon as we added the light, we got the shadows. So let me, if I remove it, yeah, it's all dark. And when I add the code back, we just get the shadows. Now the shadow is very small because it's the light is somewhere on top here. Let's move the light and see what happens. We move the light positive in the positive x direction by 100, and it's casting a shadow in the exact opposite, along the direction of the thing of the light source. So if you want like a 45-degree angle, then just make x and y the same value. And now it's become darker because of the far. So we can change that. Another other things that we can change is this map size. So if we increase it a little bit more, say 1024, I think it improves the shadow quality. Does uh, and maybe if we make it 2048, I don't know how far my computer can handle these values. Yeah, it becomes better and better if we keep increasing the values here. One thing you'll notice is that even though we have light, all the objects don't seem to be very unnaturally lit. So we have to change the material of the object itself. Let's go into the generate function. And instead of using mesh basic material, let's use a mesh form material that did something to the this. Yeah, so the back side of the object is not getting lit. It's not as red. So you can see that it's all. If I change it, if the change the material back to basic, it doesn't work. Whereas uh, if I change the material back to Fong, then it does take up the light and shadow effect. Okay. Uh, Next, what we can do quickly is we can probably look at. Okay, let's stop here and then let's come back and let's generate the a sort of a curve, spline basically, catmull from spline, and we can add it to this object here. All right, see you next time.